We're starting off a new chapter, and this chapter is chapter 12. We're going to be on lesson 1, chapter 12, lesson 1. What is the objective of the lesson? To classify and write polynomials in standard form. First of all, what is a polynomial? This is a very important question for the chapter. What is a polynomial? It is a sum of monomials. Later on, we're going to see what are monomials. So polynomials are of actually three types. One is a monomial, one is a binomial, and one a trinomial. From the words you can tell. Mono means one term. Bi, just like a bicycle, means two terms because a bicycle has two wheels. A tri, which is a tricycle, it has three wheels, so this is made up of three terms. So actually a polynomial, it's a sum of monomials which are terms. So it's made up of terms. Sometimes some of them are not polynomials. When is it not a polynomial? Two cases only. When it has a negative exponent. If I say 3x to the power of negative 2, this is not a polynomial. And when it has a denominator as a variable. If I say 2 over x, again, this is not a polynomial. So it's very important to differentiate between a polynomial and not a polynomial. Alright, let's look at this example. 3x to the second plus 5xy minus 10. This is a polynomial. 1, 2, 3. So it is made up of three terms. So it's called trinomial. If I have 3x to the second plus 5xy, then this is a term, and this is a term. It's made up of two terms, so it is called a binomial. And then you have, if I say negative 10, how many terms do I have? Just one. So this is made up of one term. It is called a monomial. I can know how many terms from the plus and minuses. These separate my terms, so I can tell how many terms are there. The next question says, are the following polynomials? If they are, you have to list the terms and you have to classify it. What do I mean by classify? Tell whether it's a monomial, a binomial, or a trinomial. So I need to say whether it is a monomial, binomial, or trinomial. Okay, let's take the first example. I have 5m negative 3 plus 2. Do I have any negative powers or exponents? Yes. So it is not a polynomial. And I move on. Number 2. If I have 3x to the second plus 8xy minus 1. Do I have any negative exponents or powers? No. Do I have any denominator of a variable? No. So yes, it is a polynomial. Now I need to list the terms. What are the terms? The terms are 3x to the second. It's 8xy. And it's negative 1. Why did I write negative 1? Because usually the negative I always have to write it down. Positive I don't have to. Okay, and how many terms is it? 1, 2, 3. So it is a trinomial. If I look at the third example, it's a negative b. Do I have a denominator of a variable? None. Do I have powers of negative? No. So yes, it is a polynomial. I need to list the terms. The term is negative b. And I need to classify it. How many terms is it made up of? It's only made up of one term, so it's a monomial. The fourth example is a 10. Does it have a denominator of a variable? No. Does it have a negative power or exponent? No. So yes, it is a polynomial. How many terms? It's made up of one again, so it's a monomial, and I need to list the terms. The term is 10. Looking at number 5, I have x plus 2 over x. Is it a polynomial? Does it have a negative exponent? It doesn't have a negative exponent, but it has a denominator of a variable. When the denominator is a variable, it is not a polynomial. And I just stop at that. Number 6, I have 3x to the second plus 6xy over 4 minus 7. Is this a polynomial? Does it have a negative exponent? None. Does it have a denominator of a variable? No. So yes, it is a polynomial. And then how many terms? 1, 2, 3. So it's a trinomial. I need to list the terms. It is 3x to the second. It is 6xy over 4. And it is negative 7. So I listed them up. The next thing we need to know is the degree of a term. It's the sum of exponents or powers of its variable. What do I mean? If I have 5x to the third, what is the degree of it? It's 3. It's the exponent of the variable. If I have 6xy, what's the degree? X is to the power of 1, y is to the power of 1, so it's 1 and 1, it's 2. If I have 5xy to the second power, what's the degree of the x? It's 1, and the power of the y is 2, so 2 and 1 make up 3. This is the degree. This is done just for you to know. It's not actually done because you cannot add x and y together. So this is just done for us to know what the degree of the polynomial is. The degree of a polynomial is the greatest exponent. What do I mean by greatest exponent? Let's say in a polynomial I have 3, 2, and 3. So what's the degree of it? It's actually 3, the largest one, the greatest. So the next question is, find the degree. If I have 5x to the third plus 8x to the second minus 9x plus 2, there is a rule here that says numbers with no variables have a degree of 0. So usually when I'm looking for the degree, I'm looking for the variables only. So if we look at this polynomial, it has 1, 2, 3, 4 terms. I need to find the degree of it. What is the degree of the first term? It's the power of 3. What's the degree of the second term? It's to the power of 2. What is the degree of the third term? It's only an x, so it's power of 1. What's the degree of the fourth term? It doesn't have a variable, so it's of degree 0. So if they ask me to find the degree of this polynomial, which is the largest or the greatest? It's 3. So the degree is 3. The second example, I have 1, 2, 3, 4, 5 terms. I need to find the degree of the polynomial. So what's the sum of the exponents in the first term? 2x, x to the second, so I have 2 x's and 1 y, so it's 3. Again, I have 1 x and 2 y's, 2 and 1 is again 3. I have 1 x, 1 y, so it's 1 plus 1, it's 2. Here I have only an x, so it's power of 1. And the 9 doesn't have a variable, so it's power of 0. So what's the degree of the polynomial here? Which is the largest? 3. So it's degree 3. Example number 3 is 1, 2, 3 terms. I need to find the degree again. P is power of 1, so it's 1. I have p to the power of 3 and q to the power of 2. So what's the degree of this term? It's 3 plus 2, it's 5. And the degree of the q is to the power of 4, so it's 4. So what's the degree of this polynomial? It's the largest between the degree of each term, which is 5. So the degree is 5. The rules for polynomials. Polynomials should be written in standard form. What do we mean by standard form? Always from greatest exponent to least exponents. So we start off, we always can reshuffle or rearrange our answer from the greatest degree to the least degree. And we have to add or subtract the like terms. Remember, an x plus an x gives me a 2x. X times an x gives me an x to the second power. This is very important. The next question is simplify the expression. They're not going to be telling you write the polynomial in standard form. You have to know that all polynomials should be written in standard form. Again, what do we mean by standard form? From greatest exponent to least exponent. So here I have, first thing I do is my distributive property. I bring it down 4m and an m to the second with the plus, and I multiply plus 2 into it. So I rewrite it as 8m plus 2m to the second, and I bring down what's left, negative m to the second plus 5. And now I add and subtract my like terms. An m cannot be added to an m to the second power. So I bring down negative m to the second plus 2m. 2m to the second gives me an m to the second. And I bring down the plus 5 plus 8m. I added my like terms, or I subtract my like terms, and I bring down what's left. Is it in standard form? No, because this is degree 2, this is degree 0, and this is degree 1. So I have to rewrite it as m to the second plus 8m plus 5. Remember always that the number without the variable is always at the end because it has a degree of 0. So this is my answer for the polynomial. The second example we have distributive property of negative 5. I bring down the a to the third plus the a. I'm distributing negative 5 into it. And so it's a negative 5a to the third plus and a minus give me a minus 5a. I bring down the 4a and I bring down the negative 3. And now I start adding and subtracting my like terms. Where are my like terms? 4a minus 5a is negative 1a. And I bring down this term because it doesn't have any other like term. And I bring down the negative 3. Is it in standard form? No, I have to rewrite it from greatest to least. This is degree 1, this is degree 3, this is degree 0. So I start off with this. So it's negative 5a to the third minus 1a minus 3, and that's my answer. The third example is this. Always remember, I cannot add a c to the second to a c to a third to a c. Each one is different because you have to only add the variables that have the similar exponents, not the ones that do not have different exponents, even if the alphabet or the variable is similar. So here I have distributive property again. I bring down my c and my 5 with the negative sign in between, and I'm distributing the negative 2, negative 2. So it's negative 2c minus and a minus give me a plus. 2 times 5 is a 10. And I bring down what I have left, c to the second plus 8c to the third minus 2c plus 10. Do I have like terms? No, because this is a c, this is a c to the second, this is a c to the third, and this is without a c. So none of them are like terms. I need to put it in order. I need to rearrange them. This is degree 2, this is degree 3, this is degree 1, and this is 0. I need to write them from largest degree to least. So I start off with the 8c to the third plus c to the second minus 2c plus 10, from greatest to least degree. The next question says, write a polynomial expression for the parameter of the figure. Give your answer in standard form. First of all, what is the parameter of any shape? The parameter of any shape is the sum of all sides. How many sides do I have? 1, 2, 3, 4, so I need to add them all together. This is parallel to this, so I have 4x plus 2 plus again 4x plus 2, because this is a 4x plus 2 and this is parallel to this, so this is a 2x plus 2x plus 2x, and then I start distributing and then adding and subtracting. 4x plus 8 plus 4x plus 8 plus 2x plus 2x. Bring down your like terms. 4x plus 4x plus 2x plus 2x, which is 12x. And the other side is plus 8, which is plus 16. So the parameter is equal to 12x plus 16. That's my final answer. The last question is, evaluate the polynomial when x is equal to 3 and y is equal to negative 2. What do I need to do? I simply need to substitute. Nothing more, nothing less. So I rewrite it as minus 2 times x to the second plus y to the third plus 1, and then I substitute, which is equal to minus 2. What's x? It's 3. So it's 3 to the second plus, what's y? It's negative 2. All of this to the third plus 1. I'm going to start working with my parentheses. Minus 2 times 3 to the second is 3 times 3, which is 9, plus minus 2 times minus 2 times minus 2. Minus 2 times minus 2 is a 4, times a minus 2 is a negative 8, and I bring down the plus 1. And now I start working with my parentheses again. Negative 2 times 9 is a negative 18, plus and a minus is a minus 8, plus 1. Two similar terms, I add negative 26 plus 1. Two different signs, I subtract and take the sign of the bigger number. So I evaluated this expression and I found that when x is 3 and y is a negative 2, this is your answer for it. As a wrap up for the lesson, you need to know, is it a polynomial or is it not a polynomial? How many terms is the polynomial made up of? Just by using the word classify it, it's made up of 3 types. You have monomials, trinomials, and binomials. You need to list its terms. You need to just list them out. you need to find the degree of each term. When I'm finding the degree of each term, I'm just counting how many exponents each term has. And then I need to tell what the degree of the polynomial is as a whole of all the terms. So what is the highest exponent between them? Polynomials should be always written in standard form, that is from greatest to least exponent. You do not add an x to then x to a second power or an x to the third. You can't, because they are different. Each one you need to find another variable with the same exponent to it. And when they say simplify expressions, you need to use the distributive property, add or subtract the like terms. And this is what the lesson is all about.